Today's daily code problem of the day is count unguarded cells in a grid number 2257. For this problem, you're given two integers m and n representing a zero-indexed m by n grid, and you're also given the 2D integer arrays guards and walls, where guards of I is going to be the row and column where the guard is standing, and walls of j is going to be the row and column representing the position of that wall respectively. So a guard can see every cell in four cardinal directions: north, east, south, or west, so they cannot see diagonally, and unless obstructed by a wall or another guard, a cell is guarded if there's at least one guard that can see it. Our goal is to return the number of unoccupied cells that are not guarded. So, how are we going to solve this problem? First thing we're going to do is we're going to take note of how exactly things are working. So the G's are the guard's positions, and taking that into consideration, we can kind of understand how this problem can work. So we have 1, 2, 3 guards and 1, 2, 3 walls. We can see that this guard can see down here. Can't really see that color. This guard can see here. This guard can see here, and this cell, which is already taken. He can see all the way to this wall, but not past it. And then this last guard can see all the way to this wall, all the way to this wall, and all the way to this wall, but his vision to the left is blocked by this wall. Again, let's go ahead and recognize that the guards do not, in fact, see diagonally. They should open their eyes, probably. I don't understand how they can't see. But let's go ahead and figure out how we're going to approach this problem. We're going to use a 2D grid to represent the board. Each cell can be in one of four states. If it's a 0, it's going to be an unguarded cell like this green one. If it is a 1, this is going to mark a guarded cell, so these red cells. If it is a 2, this is going to mark a guard. So these are where our guards are at. And then if it's a 3, 3 cells are going to mark where our walls are at. So we can kind of look at it like a priority. So 3 are the walls. These are unmovable and they don't do anything. 2 are our guards. They do traverse, however, they cannot traverse past our walls. A 1 is the spots that were traversed, and a 0 are spots that are not traversed. So, using this information, how are we going to do this? First thing we're going to do is we're going to place the guards and the walls on the grid. So we're going to mark each spot in the grid. Let's say it starts out as 0, 0. It's going to start out as a grid 0, 0. When we find out where our guard is staying, we're going to put a 1 in that position. Sorry, we're going to put a 2 in that position. And when we find out where a wall is at, we're going to put a 3 in that position. As simple as that. Then we will use our guards and traverse in all directions possible, and wherever they go, we will leave a 1 behind. Just like that. So that is how we are going to traverse this 2D array. Then we will finally count all the cells that remain unguarded or are zeros. So let's go ahead and jump into this. First thing we're going to do is we're going to make some public variables to this class, but we're going to make them private to a whole. So we're going to have private static finals. Just means that they are private to this class, cannot change, called int. And then typically when you're coding, if you have a final variable that will not change, you make it in all caps. So we're going to have unguarded is equal to 0, private static final integer. Again, static final, so we're going to make it all caps. Guarded is equal to 1. And then we are going to have a private static final integer called guard equal to 2. And then we'll have a private static final integer called wall equal to 3. So those are our four possible case scenarios, right? So in each spot in our 2D array, we're either going to have a unguarded cell, guarded cell, guard, or a wall. Next, we are going to define a helper function. This helper function is going to be how things are traversed in our 2D array. That's why we can implement it before we do our main function, is because we already know that there are four possible traversing patterns for our guards, so we could just go ahead and implement that before we do our main function. What we do need to know, though, is number one, what we're going to return, which we're going to return nothing, and number two, what we're going to put into this function. So what we're going to put into this function is first the row count, and second the column count, simply to allow us to traverse within the confines of the 2D array. And then we're going to pass it an integer array called a 2D array called grid, which is going to be our full grid, so we can update it and when we pass it back to our main function. So we have four possibilities. We could go up, we could go down, we could go left, and we could go right. And there's only a couple variables that we need to pay attention to is we don't want to run into walls, we don't want to go out of bounds, and we don't want to run into another guard. So let's implement this. We're going to have for in each integer, we're going to call them R because it's going to represent rows. So R is equal to row minus 1 since it's a zero indexed array. As long as R is greater than or equal to 0, then R can decrease. The reason we're decreasing R is because we're starting at the top of our row.
Sorry. Anyways, so in our for loop, we have the integer R is equal to row minus 1. This is going to initiate us one spot above where the guard is. So let's say I'm this guard right here. Let me get my little pen. I'm this guard right here. This is position 0, 0 up here. So by initiating at row minus 1, I'm going to, and remember, this side is rows, I'm going to initiate my start position right here. We're going to check if it's a wall or if it's unexplored, and then we'll move up. Simple as that. So we're going to be approaching 0 on the row axis. We have to keep that in mind with our logic. So in our for loop, if our grid of our column, because we're not changing column at all here, is equal to wall, or grid of R of column is equal to guard, we're going to break. And the reason we're breaking here is if we run into a wall, say we're this guard here, if the position above us is a wall, we can't do anything. Or if the position above us is a guard instead, again, we still cannot do anything, so we're going to break. Otherwise, grid of R of column is going to be equal to guarded. So we're going to update the value of that position. Remember that wall and guard are going to be initialized before we traverse the 2D array. That way, they're already going to be set. And wall is still equal to 3, guarded is still equal to 2. We're just using these variables because it allows us to understand, and it's easier to read as a programmer what exactly is going on here. Now we're going to do the same exact thing, but for every other direction a guard can traverse. So row plus 1 is going to start us one spot below where the guard currently is. As long as our R is less than grid.length, R can increment or go down. And we're going to do the same thing. We're going to check if our guard, or if our position is going to be equal to a wall or another guard. If our position is going to be equal to a wall or another guard, then we don't say text and images copied to the clipboard. Okay. So we're going to break. Otherwise, we will update that position to be guarded. Simple, right? Simple if you put your brackets in the right spot. Anyways, that is basically all we have to do here. So, because of the similarities, we can actually copy and paste this every time. However, one thing we need to keep in mind when copying and pasting is in these last two, we are going to be addressing the column instead of the row. So we're going to have int c is equal to column minus 1. As long as the c is greater than or equal to 0, c will go up. So we can paste this, but we're going to need to change this to row and then this just to c. So we're going to have grid of row and our c variable. And then we can update this as well. See. So that's it. That's all we need. We could go ahead and copy and paste that for a right, except we are going to change this to column plus 1, and we're also going to change this to as long as c is less than grid of 0 dot length, and then we'll increment c up. Other than that, everything should be the same. And now we can move on to our main function, count unguarded spots. So in our main function, we're going to do a couple things. We're going to first mark our guards. We will then mark our walls. And then mark cells traveled. And then we can count unguarded. So this is pretty simple, so let's jump straight into it. First thing we're going to do is initiate a 2D array called grid, and this is going to be our new integer array of size m by n, and this is how we're going to track our positions, what's walls, what's guards, so on and so forth. So first thing we're going to do is mark our guard positions. So for each integer array in guard, if I spelled guard right, sorry. So each integer array guard in guards, we are going to just simply mark their position. So grid of guard of 0, and then we're going to have guard of 1, and that's going to be equal to our guard value. We'll do the same exact thing for our walls. So for each integer array wall in walls, grid of wall of 0 and wall of 1, and then we can call to our function that's going to track where we traveled. So we're going to say for each integer array guard again in guards, we are going to call to our helper function mark guarded. Hopefully I didn't spell that wrong every time. And then we're going to pass it our guard of 0 as the row and our guard of 1 as the column, and then we'll press it our grid to update the grid. So the reason we have to set our guard and wall positions like this is simply because our guard and walls are given in a 2D array. So by getting a wall of 0 and wall of 1, that gets our row and column position of each guard and wall. So after we call to our helper function here, mark guarded, it is going to check all the guarded positions. Now all we have to do is simply initiate a variable called count, set it to 0, and then traverse our 2D array, which is not going to be very efficient, but it gets the job done. So it's as simple as that. We are going to then return our count. So we're going to go through each row in our grid, and for each cell in each row, we are going to check if each cell is unguarded. If it's unguarded, we'll increment our count, and then we can return our count. So if we run that, this passes our test cases, and if we submit it, it passes all solutions. Thank you. Follow for more daily LeetCode solutions. Check out my bio if you want to learn how to code today. And that's it. See ya.